Okay, we're looking at hot maths, problems, 5D, compound events in single-step experiments. Question 2, just want to go through a couple of things. Question 2, rolling at least a 4 means a 4 or more. It's a 4, 5, or 6. While we're still here, getting a 5 or 6 is probability of more than a 4. Getting a 5 or 6 is more than a 4. At least a 4 is 4, 5, or 6. Getting a 1, 2, 3 is less than a 4. And getting a 1, 2, 3, 4 is less than or equal to 4. Okay, or it's at most a 4. Actually, the last one you would say is at most a 4. So you need to know that language. At least a 4 means 4 or more. At most a 4 is 1, 2, 3, 4, the last one. All right. Okay, the next one, 2 out of 6 girls is a third. That's 33 and a third %. You should know that from percentages. 2 out of 6 is a third, which is 33 and a third %. That's C. A probability of 2 or yellow, there is 1, 2, and 2 yellows. So that's 3 out of 10. See, girls, question 5 and 6 are quite different. 2 or yellow means we want the number 2 or the yellow ones. That's 3 out of 10. But question 6 is quite different. Girls, the probability of question 6, selecting at random a disc that is 5 and blue, I can only see 1, 5, and blue. Do you see? It's not this blue one and all the 5s. It has to be 5 and blue. So we want 5 and blue, and there's only one of those. So that's 1 out of 10. If you want purple or red, it looks like each of these is a third. So that would be 2/3. In the next one, we want the probability of selecting a disc that is at most 6. So you could have 1, 2, 3, 4, 5, or 6. It's everything except for the 7 or 9. So it's 5/7. Question 10, from a normal pack of playing cards, the probability of selecting neither an ace nor, what is the probability of getting neither an ace nor a 2? Now, how many aces are there? 4 aces, and there are 4 2s. That's 8 in total. How many cards in total? 52 in total. So we don't want those 8. So we want the others, which is 44 out of 52. So we go 52 minus 8 is 44. So we want the other 44 out of 52. But, you know, some people don't have to do it that way. You know, because you've got 4 identical sets of ace through to king, if you don't want an ace or a 2, you basically want the other 11 out of each set of 13. See, there's 13 cards in each set, and I don't want the ace or the 2 in each set. So there's 11 left in each set out of 13, because we've got 52 cards in the deck. 26 are red, 26 are black. And then we've got 13 of each suit, right? 13 hearts, 13 diamonds, 13 spades, and 13 clubs, right? So you can do it that way, 44 out of 52, which will simplify to 11 out of 13 by dividing them both by 4. Remember, you can use your calculator, or if you're very familiar with card sets, you're taking out 2 from each 13 set of 13, so it will be 11 out of 13. Now, question 11. In a group of 25 students, we've got 10 boys, 15 girls. 4 boys have blue, 8 girls have blue. 1 student is selected at random. What is the probability that the student is a boy or has blue eyes or both? Organize our information. 10 boys, 4 have blue eyes. Obviously 6 don't have blue. 15 girls, 8 have blue eyes, 7 are not blue. Okay? It says 1 student is selected at random. What is the probability that the student is a boy or has blue eyes or both? Let's just read this very carefully. what is the probability that the student is a boy, or the student has blue eyes, or both? So we can have a boy, boys with blue eyes, or girls with blue eyes. So we basically want, don't we want all the boys plus the girls with blue eyes? So we want a boy or a student with blue eyes or both. How many students do we have? The students is 25 students total. Okay, all the boys is 10. Plus girls with blue eyes, we've got 8 girls with blue eyes. We've got 18 students that we're looking at. So it's 18 out of 25. All right, the language of that is a bit confusing. Question 12. In a group of 50 students, we've got 38 boys, 12 girls. 18 boys have blue eyes. And similar question, 8 girls have blue. So that means we've got 4 girls that are not blue and 20 not blue. Student is selected at random. What is the probability that the student is a girl? So we want a girl that doesn't have blue eyes. So it looks like we want these 4 kids out of, how many students altogether?
50.
Out of 50. Now, as a percentage?
8.
Yeah, that's 8%. You can just look at it like this. Isn't that 4 out of 50 times by 2? It's 8 out of 100. That's 8%. Andrew and Ben make up a game using a normal deck of cards. The rules are simple. Draw a card at random from the pack, and you win if you draw a jack, queen, or a king. That's you win. Now, how many jack, queens, or kings are in every set of 13? No, there's 3. Oh, yeah, sorry. Remember, there are 4 jacks in the set of cards, 1 of each type. 4 queens and 4 kings. So, we've got 4 jacks, 4 queens, 4 kings. We've got a total of 12. They're called the picture cards. There are a total of 12 picture cards. A deck of cards has 52 cards. So, the chance of winning, the probability of winning, is to pick those 12 out of the 52. But if you know your deck of cards quite well, if I just look at, because we've got 4 identical sets of numbers. We have the ace, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Jack, queen, king for each suit. Remember, there are 4 suits. So jack, queen, king there are 13 cards altogether, because you've got 10 numbers, if we can call the ace a 1, and you've got the other 3, jack, queen, king. So we've actually got 3 picture cards out of 13. If you divide these both by 4 or put it on your calculator, you get 3 out of 13. So the probability of winning is 3 out of 13. So Ben, now, so what happens is Andrew and Ben are playing this game. Ben wins on his first turn. Now, if Ben wins, he's picked out one of those 12 cards to win. Ben wins on his first turn and does not return the card to the pack. That means that there are only 11 picture cards left out of 51 cards left, because he did not put the card back. So what is the chance that Andrew will win? It's 11 out of 51. Because Ben has removed either a jack, queen, or king, and there were 12 of those. He's taken 1 out, and now there's only 51 cards left instead of 52. Okay? Someone was just saying, so Andrew now has more of a chance. We won't know if he has more of a chance unless you work out what these work out to be. So if someone can get a calculator out, Ben was 12 out of 52. You need to work it out as a decimal. Andrew is 11 out of 51. If you want to see who has a better chance of winning, you'd need to divide those numbers as a decimal. Has anyone done that? 0 point, 0 point. Who has the better chance of winning? It's Ben. Ben's probability of winning is higher than Andrew's. 0.23 is higher than 0.21, 0.21568. So Ben has a higher chance, has a greater chance of winning. So you would, like, if you're asked a question, is this game fair or who has a better chance of winning, you use probabilities to work that out. Whoever's got the highest chance or probability, remember probability is chance, whoever has the greatest fraction, and you can only compare fractions if the denominators are the same or if you convert the fractions to decimals. See how I could not compare them unless I've changed them to decimals or the same denominator? We're not going to give them the same denominator. It'll take too long. Question 14, there are 20 apples in the box. The probability of selecting a red, probability of red is 40%. So what the probability of bruised is 30%. From this, Sam decided that the probability of selecting a red or a bruised is 70. That is not right, because some of the red ones could also be bruised. So it is not correct always. It would only be correct if none of the bruised apples are red. So the answer is C. This question, if all of the bruised apples, so as I said, it was C, it would only be 70% if none of the bruised apples were red. Now, if answer B, so let's say answer B, if all of the bruised apples are red, then the probability of selecting a red or a bruised would be 40%, because all these 30% bruised apples are red. So that's 30%, and there would be another 10% of just red apples that aren't bruised. So B would be the answer if they were asking for 40. If B was the case, the probability would be 40%. Same with D. If D was the case, if all the red apples were bruised, that means of these 40% red apples, 30% in that total are also bruised. So the probability of red or bruised would be 40% as well for this option here for D. Question 15, from a normal deck of playing cards, what is the probability of selecting a card that is either red or greater than 10, or is a club with a value at most 5? So remembering we've got our 4 sets of 13 cards. So we want a card that is either red and greater than 10. So here are my red ones. Greater than 10 would be Jack, Queen, King. Reds are hearts and diamonds. So with this either red and greater than 10, it's got to be red and greater than 10. That's those 6 cards. Or a club with a value at most 5. Now clubs are black and they look like this type. Club at most 5 would be ace, 2, 3, 4, 5. We're looking at those 5 cards. So we've got these 6 there and those 5. So it would be 11. 6 and 5 is 11 out of 52.